Welcome to my channel Living Linux. In this video I want to have a look at Rusticl. It's an open source OpenCL implementation written in Rust. The developments have already been started like a couple of years ago. Back in those days I think it was a bit more complicated to get it working. But nowadays, at least for some platforms, it's relatively easy to get it working. So let's see. I'm on a ARM Rockchip RK3588 with the Mali-G610 panfrost driver, or nowadays actually it's also panthor. I built an Armbian image based on Ubuntu Plucky. And you can see Linux kernel 6.17.3, but I think that is less relevant here. The more relevant part is that you have the panfrost driver for the Mali-G610, and in this case based on Ubuntu Plucky, and that has Mesa 25. And let's just say, yeah, the thing that you need to install is, well, at least I had to install the mesa-opencl-icd, and just to be sure I also installed opencl-headers. clinfo is just to have a look at the info. And you can also install clpeak just to do a simple benchmark. Now I have already installed those, but yeah, just to show you the example. Now it's not enabled by default, at least not with Mesa 25. So if we do clinfo now, you can see no devices found, no devices found, no devices found. Now, you can enable it with an environment variable for a couple of platforms. So these should be supported. This one seems to be experimental, but hopefully in the future that will improve. This one is relevant for the Mali-G610. But yeah, from my experience, it could be that this documentation is based on a newer version of Mesa, but at least with Mesa 25.0, it's not fully implemented. Let's put it like that. So if we enable Rusticl, and now we do clinfo again, you can see that it has found the Mali-G610 with the panfrost driver. So I already ran clpeak, and yeah, just pause the video if you want to have a look at some of these numbers. You can see that half precision is not supported at the moment, double precision not supported at the moment. I'm not really sure if they can enable everything, because the integrated GPUs, they only consume like a couple of watts, so you can't compare them with like the discrete GPUs from NVIDIA, AMD or Intel, which can consume like more than 100 watts. So yeah, that difference has to come from somewhere. So here are the numbers, but like I said, I think they still need to get everything working, so hopefully these numbers will improve in the future. Now these benchmarks like clpeak, they might not be so interesting. So let's just do something that will show you something. And in this case, Mandelbulber 2. So yeah, I already configured it to use OpenCL. So you can find that in the preferences, OpenCL. You can also see that there is an entry for Clover, but I think that one nowadays is deprecated. And there's no GPU device. So just use Rusticl and you can see that it uses the Mali-G610. Now as a comparison, first we'll do no OpenCL, so it's running fully on the CPU. And at first that is quite fast, but the more you zoom in, the slower it becomes. So let's just have this monitor also here. Sorry. Oop. So if we render, then you can see that the CPU load goes up. And once it's finished, then the CPU load goes down. Now, we can also run it with OpenCL. Now, it needs to compile the OpenCL program first. That can take quite a while. So, yeah, I'll put a chapter timestamp in the video so you can skip to the result. But once it's compiled, then it's a whole lot faster than just running it on the CPU. So we just let it compile. And you can see that it doesn't use all the CPU cores for the compilation. Not really sure if the compilation actually happens on the CPU, but I assume it does. And as you can see, yeah, the compilation can take quite a while. But at some point in time, it should be ready to run. And I also tested this with the closed source driver from Rockchip. And from what I remember, that the compilation was a lot faster there. Well, here we get the result. Well, as you can see, the Rusticl driver is not fully compliant. Let's put it like that. I do get an error message, but it seems to be working. And now when we zoom in, you can see that it calculates it a whole lot faster than on the CPU, especially once you have zoomed in a lot. Now you can also, for instance, go with fast, and then it needs to compile the OpenCL program again. But I think this one should be a bit faster. Yeah, but then I have the feeling that it sort of renders monochrome, something like that. I'm not really sure if it's supposed to be like this, but let's just say we go back to full. And then, well, at least I have the impression that there's more color. So, well, at least the good part is that we can start working with OpenCL, but as you can see from the error messages, it's not really fully compliant yet. But the good part is that we have an open source OpenCL driver for the ARM Rockchip RK3588 with the Mali-G610. It still needs some work. Yeah, hopefully once I have Armbian with questing Quokka, I'll do a test again and see if we have any improvements, because I think so this one is with Mesa 25.0. Questing Quokka, I think it comes with Mesa 25.2. So yeah, hopefully we can see the improvements in a not too far future. This is all for now, and I hope to see you again in my next video.